Hello, good people. How are you? Welcome back to Math Zone African Motives, your favorite channel. We are still into our grade 11 physical sciences for term 4. We are looking into the topic types of reactions, specifically doing redox reactions. So, our first video was on introduction, where we introduced and defined what we term an oxidation number or oxidation state and how we use it. Now we want to dive deep into redox reactions. So for those who did not manage to actually get to watch lesson 1, may you please find time to go back to lesson 1, because that is where we started, and the basics that we got from that lesson are the ones that we want to use as we go forward. Now in this lesson, at the end of it, we are supposed to be able to describe a redox reaction as in involving electron transfer. And we are also supposed to describe a redox reaction in terms of changing in oxidation numbers, where we know that with redox reaction, there is always a change in oxidation number. And then we are supposed to be able to identify a redox reaction, apply correct terminology to redox reactions. For example, oxidation, reduction, oxidizing agent, as well as a reducing agent. So by the end of this lesson, we are supposed to be able to do these three listed scopes. Now let's get started and get to start identifying and defining what we refer to as what redox reactions. So the definition that we are going to go with is that a redox reaction is one that involves oxidation and reduction. So maybe I can simply use the word itself to define what it means. So from the word, you can see that I can actually get to divide it into two, where red would be meaning what? Reduction. And where ox would be referring to what? To oxidation. So we are simply saying that redox reactions, they are in reactions that involve both reduction as well as what? Oxidation reactions. So some they can define redox reactions as reactions that involve electron transfer. Whenever there is transfer of electrons, there is either an increase in the oxidation state or else decrease in the oxidation state. Now, when we have increase in the oxidation state, this is where we are saying it's oxidation. When we have decrease in the oxidation state, this is where we are saying we have got what? Reduction. So whenever we have got electron transfer, let's get to know that we have got what? We have got redox reactions. So now let's define what oxidation means. Oxidation is simply the loss of electrons, which is increase in oxidation number, while reduction is gain of electrons, that is decrease in the oxidation number. So like I said, for you to understand more, you need to go back and actually define what an oxidation number is, so that you would know when an oxidation number is increasing and when an oxidation number is decreasing. Now, since we have said that a redox reaction involves both a reduction and oxidation reaction, it simply means that there is an element that is going to be what? That is going to be oxidized, and there is an element that is going to be reduced. So the one that gets reduced is what we refer to as the what? As the oxidizing agent. And then the one that gets oxidized is the one that we refer to as the what? As the reducing agent. So an oxidizing agent is simply that element that receives electrons, or else the one that causes oxidation. So by it causing oxidation, it leads to itself being reduced. And then the reducing agent is the one that loses electrons to get oxidized while it is causing what? Reduction. So that is how we define oxidizing agent and reducing agent. And we've seen how we define oxidation and reduction. Now, for example, if you are given the reaction between zinc and copper 2 plus ions to form zinc 2 plus ions and copper, you can see that from our definition of oxidation state, zinc here is having 0, and then here it is now having a what? A 2 plus. While here copper is having 2 plus, and here it's now having 0. So we can clearly see that zinc is increased in its oxidation state. And we say that once an element increases in its oxidation state, it has been what? It has been oxidized. It has been oxidized. And then when an element reduces or else decreases in the oxidation state, we say that it has been what? It has been reduced. So reduced meaning to say that we have reduced the oxidation state. Oxidizing meaning to say we have oxidized or increased the oxidizing state or the oxidation state, sorry. So you can see that here copper has been reduced. So in itself, it's an what? It's an oxidizing agent. The one that gets reduced becomes an oxidizing agent. Why? Because it is oxidizing zinc to zinc 2 plus. And then the zinc has been oxidized. Since it has been oxidized, it becomes the what? The reducing agent. Why? Because it gets oxidized and it causes reduction in what? In copper 2 plus ions. So that is how we identify oxidation reactions and reduction reactions, as well as identifying the element that is being what? Oxidized and the one that is being reduced. So we can simply say that zinc is oxidized, so it becomes the what? The reducing agent. It is oxidized. The oxidation state is increasing, so it becomes the reducing agent. While we are saying that zinc metal will lose electrons, so it loses what? 2 electrons. So if we are to write this as an equation, we call this a half reaction. So according to this half reaction, we can say that the zinc is losing 2 electrons. And we know that loss of electrons is what? Oxidation. And then if we come to copper, we can actually simply see that copper 2 plus is reduced. So it becomes the oxidizing agent. It has been reduced from 2 plus to what? To 0. So its oxidation state is reduced. So it becomes a what? It becomes an oxidizing agent. So copper 2 plus ions gains 2 electrons to form what? Copper metal. So if we are to write it as a half reaction, it becomes copper 2 plus aqueous plus 2 electrons. It gains 2 electrons to form what? Copper metal. So these are what we refer to as what? Half reactions. And half reactions, they simply define or else shows us the other part of the redox reaction, which is either the what? The oxidation part or the reduction part. So we now want to see how we identify redox reactions. We can identify redox reactions by simply looking at the oxidation states, the oxidation numbers. Is there a change, like the example that we have simply done there, where zinc metal was reacting with what? With copper 2 plus ions to form what? To form zinc 2 plus ions plus copper metal. So you can see that there is oxidation of zinc, or else there is change of the oxidation state between zinc metal to zinc metal ions. Whilst here we also have got what? A change in state from what? From 2 plus to 0, which is from copper 2 plus ions to what? To copper metal. So once we have got change in the oxidation numbers, then it means that there is what? There is reduction reaction. So we can identify redox reaction by simply looking at the what? At the oxidation state. Is there a change in the oxidation state? So by looking at how the oxidation number of an element changes during a reaction, we can easily see whether that element is being oxidized, which is to lose electrons, or else being reduced, which is to gain electrons. If the oxidation state does not change, it simply means that that is not a redox reaction. It can either be an acid-base reaction or else an acid-base neutralization reaction. For example, when you react sodium hydroxide plus what? Hydrochloric acid. You can see that the oxidation state of sodium here, it was just +1. And then after, it is now also at +1. There is no change in oxidation state. If you look at hydrogen, also there is +1 here, and then here it will be +1. For chlorine, -1, and also here to be -1. The hydroxide ions, they will be having -1. When they come here, also they will be having what? An OH minus. So there is no change in the what? In the oxidation state. So once there is no change in the oxidation number or oxidation state, then we say that it's not a redox reaction. Redox reactions occurs only when the oxidation numbers what? Change. So now we come to where we were actually saying that we have what we refer to as what? Half reactions. So on our half reactions, from our previous example, we said that half reactions, they represents either the oxidation part or else, pardon me there. Let me return to that slide of ours. So we are saying that half reactions, they represents either the oxidation part or the reduction part. So we can define a half reaction as either the oxidation part reaction or else the reduction part reaction. That is what we refer to as the what? As the half reaction. For example, if you are given magnesium, which is a magnesium metal, reacting with what? With chlorine, and then forming what? Magnesium chloride. We can see that this is now in ionic form. So here we will be having what? Magnesium 2 plus and chlorine minus. Whilst this side I was just having magnesium with an oxidation state of 0 and then chlorine with an oxidation state of what? Of 0. Which simply shows that for magnesium there is an increase in the oxidation state. So this is what? Is oxidized. Since it's oxidized, it can actually form our oxidation reaction. So we will see that when we oxidize something, it is losing electrons. So we are removing electrons. So magnesium has lost what? 2 electrons. So this becomes its a half reaction. So this half reaction represents what? The oxidation part. Whilst for chlorine there, we can simply see that chlorine has been what? Reduced. Its oxidation state is reduced. So it has been what? Reduced. So we can write the reduction reaction from what? Chlorine to what? We can say that chlorine, for it to move from a negative, to move from 0 to a negative, we need to receive what? Electrons, so that it can form what? Chloride ions. But definitely we need to balance these atoms. So here we'll be having 2. So here we'll be having also what? 2 electrons. So this becomes a half reaction for the what? For the reduction part. So these are what we refer to as what? As half reactions. They simply represents either the oxidation part or the reduction part in a redox reaction. So you would have just written them like this. This becomes the what? The oxidation half reaction. Whilst this one becomes the what? The reduction half reaction. So these are the half reactions. Now let's look at what? At balancing redox reactions. How do we balance redox reactions? Uh, like we have seen in our two half reactions for a redox reaction, that the number of electrons that are donated are supposed to be exactly as the number of electrons accepted. What am I saying? Let's go back to our slide. So you will see that here magnesium lost 2 electrons, whilst chlorine gained what? 2 electrons. So the number of electrons that are lost and the one that are gained are supposed to be exactly what? Equal. So if they are supposed to be exactly equal, we now get to use this to balance our what? Our redox reactions. So that is the information that we use to balance our what? Our redox reactions. So we are saying that, for example, we are given a question here. It is saying balance the following redox reaction. How do we balance this reaction? So there are some steps that we need to simply follow. So for example, the first step, we need to write down the what? The half reactions. Pardon me there, I do not know what's happening with my machine. I'm sure at some point in time it is a bit tired. But anyway, let's continue. So we are saying that first we need to write down the half reactions. After writing down the half reactions, so what do we mean by the half reactions? You can see that iron is being oxidized to what? To iron 3 plus, whilst chlorine is being reduced to chloride. So these are the two half reactions. After writing the half reactions, we need to balance the number of electrons. We need to balance the what? The electrons that are being transferred. Why? Because we say that the number of electrons being transferred, they need to be necessarily equal. After balancing the number of electrons, we then now get to combine these balanced half reactions. So we come to what? To combine them. We combine the what? The balanced half reactions. After combining the balanced half reactions, we then get to just cancel out the what? The electrons that are taking part, because you will be having the same electrons on the on either side. So we then get to cancel them and write our final what? Our final balanced redox reactions. So these are the steps that we follow. So let's actually get to look onto these steps, looking at this example that we are given here. So you would see that we say that we need to write the what? The half reactions. So the first half reaction would be to say iron 2 plus is actually forming what? Iron 3 plus. So you would see that for iron 2 plus to form iron 3 plus, it simply needs to what? To lose an electron to become more positive. So it will need to lose an electron. It is losing one electron to become more positive. And then for chlorine, we are having chlorine forming chloride ions. But you can see that for it to form a negative, it needs to gain an electron this side. So this is where we actually get to say that the chlorine would be gaining what? An electron. But you can see that we have got 2 atoms of chlorine this side. So we need also 2 atoms of chlorine. We need to balance these atoms. After balancing those atoms, we simply see that here also to have 2 chloride ions, we would have gained what? 2 electrons. So now we have got these half reactions. But you would see that the number of electrons being gained by chlorine are more than the number of electrons being lost by iron. So we now need to balance electrons here. What do? We can come and actually get what? To multiply by 2. So that at the end of the day, we'll be having 2 electrons being lost by iron. So you would see that you would have 2 iron 2 plus to form 2 iron 3 plus plus 2 electrons. Whilst you are going to be having here your chlorine, it will be gaining 2 electrons. to actually get to form what? 2 chloride ions. So after we now have got what? Balanced half reactions. We now need to combine these two balanced half reactions to make one complete redox reaction. So how do we combine them? We take everything that is on the what? On the left hand side. We combine everything that is on the left hand side and also combine everything that is on the what? On the right hand side. So if I take everything that is on the left hand side, I'm going to have 2 ion 2 plus chlorine plus 2 electrons to form what is on my right hand side. I would have what? 2 ion 3 plus 2 electrons plus I would have 2 chloride ions. After having those, this is where we say that we now get to come and cancel out these electrons, because we have got 2 electrons on the right hand side, 2 electrons on the what? On the left hand side. If that is the case, we now get to rewrite this equation as one balanced equation. So it will now come to be 2 ion 2 plus, which is an aqueous, reacting with chlorine. Also here it will be an aqueous. And then we get to form 2 ion 3 plus, which is an aqueous, plus 2 chloride ions, which are just in aqueous. So we now have got a balanced what? Redox reactions. So after I've said that, let me just get to show you what you were just supposed to do, the steps that you were supposed to follow, and what you were supposed to get there, which is just the same thing that I've done here. But now I just want to show you in a more clearer way. So these are the steps that you're supposed to be following. So first, you need to write your half reactions. And these are the half reactions. And when we say half reactions, you need to actually get to write the full half reactions where you are saying iron 2 plus forms iron 3 plus. How does it form iron 3 plus? It needs to lose an electron. And then chlorine forms 2 chloride ions. How does it form a chloride ion? It has to gain electrons. And then now, looking at the what? At the electrons, we need to balance the electrons being lost and the electrons being gained. So we just multiply by 2 throughout, so that we would get 2 ion 2 plus to form 2 ion 3 plus 2 electrons. And then chlorine plus 2 electrons to form 2 chloride ions. So ion has lost 2 electrons, while least chlorine is gaining 2 electrons. After having the balanced half reactions, we now combine these two half reactions. So I will take everything that is on my left hand side to say 2 ion 2 plus, this is 2 ion 2 plus, chlorine, 2 electrons, 2 electrons, to form 2 ion 3 plus, 2 electrons, and then 2 chloride ions. And then now I just get to cancel out the electrons. So I just come and cancel out the what? The electrons. And then thereafter, I now rewrite my final what? My final answer. So these are the simple steps that you follow when you're balancing what? Redox reactions. But you would see that the steps that we have just listed there, we did not, or else we were not considering if the reactions are occurring in acidic or else in basic what? Solution or medium. Now, however, if there exist hydrogen or else oxygen atoms on either side of the what? Of the equation, that is to say that the reaction maybe is occurring in acidic or basic, we now need to consider the medium. So let me rephrase. If hydrogen atoms or else oxygen atoms, they appear on one side of the equation but not on the other side, we now need to consider the medium in which the reaction is occurring. So From the example that we have, let me just take you back. You can see that the reaction from either side, there is no hydrogen or else oxygen atoms appearing here. Hence, therefore, there was no need of us considering if the reaction is occurring in acidic or basic. But once there happens to be some hydrogen or else oxygen atoms in either side, what am I saying? For example, you might have hydrogen sulfide reacting to form what? Sulfur. And then you might have, maybe you would be having what? Let me say chromate, where you have got chromate ions reacting to actually get to form what? Chromium 3 plus ions. You can see that on the left hand side, I've got oxygen atoms, but on the right hand side, I don't have oxygen atoms. On the right hand side, for this one, I've got hydrogen atoms, but on the right hand side, I don't have. So I'm saying whenever you have your oxygen atoms or else hydrogen atoms appearing on either side of the reaction, but not on the other, this is where we now need to start considering the medium at which the reaction is occurring in. Is it acidic? Is it basic? So here, this is where they said, for example, if there is hydrogen or oxygen in reactants and not in products like we saw there, or vice versa, then we need to know what medium the reaction is taking place in. This will help us to actually get to what? To balance these hydrogen and oxygen atoms correctly. Why? Because we know that oxidation is also defined as the gain of oxygen atoms. And then reduction is also defined as the loss of what? Of oxygen atoms, or else gain of hydrogen atoms. So now let's look into how we actually get to balance when we have got acidic medium. If the reaction takes place in an acidic solution, we need to add water molecules to balance oxygen atoms. And then we add hydrogen ions to balance hydrogen atoms. The reason being, according to Arrhenius, an acid in water releases what? H plus ions freely. So if we use H plus ions, we can be able to balance the hydrogen atoms in an acidic solution. But we have to remember that our net ionic equation that we are going to be writing should not include or else involve what we refer to as spectator ions, the ions that are actually not taking part in the reaction. What do we mean by that? Those ions that are not changing their oxidation, what? Their oxidation state in a redox reaction. It simply means that they are not taking part of the what? Of the redox reactions. And these are called what? Spectator ions. So they are not included in the net equation. Now, what about if you are now having a basic medium where the reaction is taking place in a basic solution? The difference comes to say, when you are now balancing hydrogen atoms in a basic solution, you need to add OH ions. As we have quoted Arrhenius, we are saying that according to Arrhenius, a base in water releases what? OH minus ions freely. So we know that our scientists say, Arrhenius said that if we are to actually have or to term something a base, it has to release water in what? In OH minus ions. So to balance oxygen atoms, you simply add water molecules like you do when it's a what when it's in acidic solution. So the difference comes to say, when we are balancing what? Hydrogen atoms. In acid, we add what? H plus. In acid, we add H plus, and then in basic, we add OH minus. So under basic solution, add OH minus. Under acid solution, add what? H plus ions. That is the simple difference that is there. Now, let's look at an example. So here the question was saying, balance the following redox reaction given that you have got this reaction here. So this is a redox reaction of what? Of chromate ions that are reacting with hydrogen sulfide to form chromium ions plus what? Plus sulfur. Now they are saying that the reaction takes place in an acidic medium. So we say that in an acidic medium, we add water molecules to balance what? Oxygen atoms. And then we add H plus ions to balance what? Hydrogen atoms. That is what we simply need to do there. But we also have steps that we need to what? To follow. That are same as the ones that we have been doing. The one that we did when we were not considering the medium. Like for example, we need to first write the what? The half reactions for each. So how do I identify my half reactions here? I've got chromium going to chromate going to form what? Chromium ions. And then I also have another which is hydrogen sulfide going to form what? Sulfur there. These are the two half reactions. So I just come and list them down here. After that, I now need to balance my what? My number of atoms that appear on my what? On my left hand side. They have to appear on the what? On the right hand side. And they have to be of equal magnitude. They are supposed to be equal in number. So here I've got what? I've got 7 oxygen atoms. But you can see that this side I don't have. So I need to what? To add water. After adding water, I will see that I need 7 oxygen atoms. But however, now I've created another problem. I now have got 14 hydrogen atoms. How do I get hydrogen atoms this side? This is where we say add hydrogen ions. So now here I've got what? I've got 14. So I need to have what? 14 this side. So this is the reaction. This is the reaction. So you can see that the reaction that we have done is chromate plus 14 plus H plus ions, and then to form 2 chromium what? Ions. We also need to balance for what? For chromium. Because I've got 2 chromium here, I need to have what? 2 chromium this side. So I would have just came and what? Multiply by 2. So that I can have 2, and then I've got what? So I've got balanced number of atoms from my left hand side to my right hand side for this half reaction that I wrote there. After that, I now need to do the same for the half reaction of what? Of hydrogen sulfide. So for the one hydrogen sulfide, I see that I've got hydrogen this side. So this side I need to add what? Hydrogen ions. But I've got 2 hydrogen atoms. So I also need to have 2 hydrogen what? Atoms. So being that the case, that becomes our what? Our reaction there. Now that we have balanced the number of atoms on either side of the arrow, we now need to simply balance the what? The charges. We now need to balance the charges because we've got the law of conservation of charges to say that the charge that is on the left hand side, it has to be equal to the charge that is on the right hand side. How do I balance those charges? So on the left hand side here, I can see that I've got 14 plus, and then I've got 2 minus. So these ones in total, they'll give me what? They'll give me 14 minus 2, which is equal to plus 12. So on my left hand side, I've got what? Positive 12. I've got a charge of positive 12. And then on my right hand side of the arrow, I've got 2 times 3, which is positive 6. How do I balance this? The simplest way to do is to add the number of electrons that will give the difference there. So the difference between 12 and 6 is what? 12 minus 6 is 6. So I'll add 6 electrons there. So that the number of electrons will provide the negative charge that will subtract on this positive charge that I'm having this side. So you will see that at the end of the day, this would also be equal to positive 6. Because if I say positive 12 minus 6, I would get what? Positive 6. Now the charge would have been balanced. So I would have just came here. Allow me to reduce the font of my. Okay. So I would have just came here and said chromate 2 minus plus 14 H plus what? 6 electrons to later form what? Two two chromium ions plus 7 water molecules. So I can actually get to see that this reaction is now balanced. Now I need to go and balance the what? The number of charges as well here. So the charge this side is a positive 2, but this side is a 0. So if this side is a positive 2 and this side is a 0, what do? I need to simply add 2 electrons so that these positive 2 and 2 electrons, they'll cancel out to give me what? 0. So I would have just came and actually written what? I would have just came there. I'm having chromium 3 plus ions. Here I would have just came and added what? 2 electrons. That becomes a balanced what? A balanced half reaction. So this is what you would see here. So these are the what? Are the balanced half reactions, where we are saying that we add electrons to balance the charges. And where do we add the electrons? We add electrons to the side that is having a greater positive charge. And after we've done that, now we can see that we've got a challenge of saying here we are gaining what? 6 electrons. So we are gaining 6 electrons. But here we are only losing what? 2 electrons. So how does this actually balance when the other side is losing 2 and the other side is gaining 6? We need to balance these electrons. So we can actually get to what? We multiply by 3 so that we can have also how many? 6 electrons being what? Being lost, so that they become the ones that are being gained here. Because this reaction is just one redox reaction. That time when chromate is gaining, also hydrogen sulfide is also what? Losing. So we need to balance this. So by multiplying that, I would have just came and have what? 3 hydrogen sulfide to form what? 3 sulfur plus 6 hydrogen ions, because if I say 3 times 2 it becomes 6. And then after that I would form 6 electrons. Now it's now balancing in terms of number of electrons. And then after that I now need to combine these two. So what would actually get to happen is this is what you are now seeing here. So the following step, which is step number 4, is to balance the what? The number of electrons, and then combine the two half reactions. So here we are having a what? A balanced reaction. So we are having a balanced half reaction for our chromate ions, a balanced half reaction for our hydrogen sulfide. Now, since they are all balanced in terms of charges, in terms of electrons, we can now get to combine these two. Now, when we are combining, we just do the same that we have done. We take the left-hand side, all of it, we combine it. So we are going to take this left-hand side here, this left-hand side here, and then we combine with that left-hand side. Then they become one. So chromate plus 14 hydrogen ions, and then 6 electrons. So we get, so we have this, and then it reacts with that. So at the end of the day, what we are supposed to be finding there, we would actually get to find what? This on our left-hand side. On our right-hand side, we are also going to what? To combine everything that is on our right-hand side here, as well as everything that is on our right-hand side here. We combine it, it becomes one. So we have got 2 chromium ions, 7 water, 3 sulfur, 6 hydrogen, and 6 electrons. So after that, we now need to look at our what? At our combined reaction. So these two half reactions have been combined to form this. But however, you can see that on this side, I've got 6 electrons. This side as well, I've got what? 6 electrons. I can simply cancel them out. After that, I'll need to look at also what is similar in both sides. I've got 6 hydrogen ions this side, and then I've got 14 hydrogen ions this side. So I can simply subtract these 6 hydrogen ions this side, and then they'll be cancelled out. This side also, I subtract 6, I'll be left with what? I'll be left with 8 hydrogen atoms, 8 hydrogen ions. So after doing that, I can now rewrite my final what? My final equation after doing that. So this becomes these chromate ions, they are here, plus I now add 8 hydrogen ions. After subtracting 6, I would get what? 8 here, and then 3 hydrogen sulfide, that is 3 hydrogen sulfide, and then I now get to what? To form 2 chromium ions. These are 2 chromium ions, and then 3 sulfur, 3 sulfur, 7 water, 7 water, and then these ones they cancel out. So that is how we simply what? Balance our redox reactions. Given that we have hydrogen or else oxygen atoms appearing on either side but not on the other side. So we now need to know, is it occurring in an acidic or basic medium? After that, we apply rules to do with acidic solution, which is to add what? H plus ions when we are balancing what? Hydrogen atoms. But if it is in a basic, we now get to add what? OH minus ions. Now, you would see that everything that we have done, we could have just used what we refer to as what? Standard reduction potential tables. So these tables are the ones that are being used to make our life easy. But however, a question might just simply come exactly wanting you to do as we have done here. You see, it would simply want you to do this. It would want you to follow these steps. So a question might come and actually get to say that balance the following redox reaction if the reaction takes place in an acidic medium, and show all steps, and then they would give you what? They would give you 7 marks. It simply means that you now need to actually get to what? To illustrate these steps that we've been doing here. But however, though, they might actually get to state that use the what? The standard reduction potentials to actually what? Balance the redox reactions. This is when you come, you either pick table 4A or else table 4B. Now you would see that table 4A and 4B, they are just the same. What do we mean by that? They are just the same. You would see that table 4A is written in terms of increasing oxidizing power. What do I mean by that? You can see that as we are going up, we are increasing the oxidizing power. So my fluorine here has got a higher power of losing to form a negative because of this positive. So it has got a higher affinity of electrons. It needs to gain electrons. It is hungry of electrons because of this positive. And then as we are now going down, we are losing this positive. So it means we are losing this affinity. So it simply means that we are now increasing in the reduction what? In the reduction strength. This is where we will now become, or else we will go up until we get to what? To negatives. But you see that 4B, it is written in terms of increasing reduction strength, where you would see that lithium has got what? It has got lesser affinity for electrons. So it is more prone to reduce another than to what? To oxidize another. That is what it simply means there. So other schools, they use 4A, others they use what? 4B. But it depends with which one you are more familiar. But they simply mean the what? The same. So we are saying that the higher the positive, the more oxidizing power it has. The higher the positive, the more oxidizing power it has. And what is oxidation? We said oxidation is loss of electrons. So this positive, it shows the higher affinity for electrons to make the other to lose so that it can gain itself. So fluorine actually wants to gain so that the other that would be in reaction with fluorine would lose. So that is why we are saying the higher the positive, the higher the oxidizing power. So this will oxidize. So we are saying fluorine would actually get to oxidize what? Cobalt. So cobalt would actually get to lose when it reacts with fluorine. So you would see that fluorine would actually react in this manner to form what? Two fluoride ions. Whilst cobalt would come and react in this manner. So it simply means that cobalt would instead lose so that this would gain. Let me just use a different color to show my arrow there. This is where my arrow is. So I'm saying cobalt would lose so that this can gain. So we are saying that cobalt has been what? Has been oxidized. So you can see that fluorine is having a what? A higher oxidizing power. It can oxidize cobalt. So fluorine would oxidize everything that is below it. So in actual essence, we are saying fluorine would react in this manner every time that it is reacting with everything that falls below it. So if you are used to 4B, you can also use the same concept to say that if I'm having lithium, since it is having a more negative, so it shows that it has got a what? A higher reducing power. A higher reducing power. And what is reduction? It is loss of electrons. So you are going to, reduction, it's actually gain of electrons. So you are going to actually get to what? To see that lithium would react in a format of saying what? Lithium to actually get to what? It will lose its electron so that the other will gain. When the other gains, it becomes what? It becomes reduced. So it has reduced everything that is below. So if, for example, it reacts with what? If it comes and then it reacts with, let me get to take maybe, I want to take something that is below it that is having a negative. So if it comes, it reacts with this sulfate ions. Maybe let's say lithium is reacting with sulfate ions. You would see that sulfate ions will react in this format. You would come and have SO4 minus 2 minus plus 4H plus 2 electrons to actually get to form what? Sulfur dioxide gas. So we are saying that lithium would instead lose whilst this one is gaining. So this one has got a higher reducing power than what? Than your sulfate. So you can see that as we are going down, we are increasing the oxidation power, the oxidizing power. Whilst when you are going up, we are increasing the what? The reducing power. That is how you use these two what? That is how you use these two tables. So I would advise that we stick to the one that we are used to. If you are used to using 4B, use 4B. If you are used to using 4A, you use 4A. But one thing that I would advise is that it is just the same. You only need to know which side are we increasing oxidizing power and which side are we decreasing the oxidizing power, so that you can be able to pick through the half reactions. So you can see that here we are given the half reactions in order of their reactivity series, in order of their oxidizing power or reducing power. So that is how we use these tables. But however, we are going to have our third video that will focus more on answering and attempting questions on everything that you have done. And this is where we are going to use exclusively the what? These tables where they state to where they state us to what? To apply these tables. So let's meet in our what? In our final and next video for term 3. Thank you for being together, guys. Let's meet in our next video.